In 6th grade, we look at the numbers we use every day in two different ways, as factors and as multiples. These concepts are like two sides of the same coin. Factors are the numbers that build a number through multiplication, while multiples are the results you get when you multiply a number by others. Our main goal is to find the greatest common factor, GCF, and the least common multiple, LCM, because these help us solve problems with fractions and real-world scenarios. Let's start with factors. Factors are numbers that divide evenly into another number with zero remainder. Think of them as the ingredients for a recipe. Factors always come in pairs. For instance, the factors of 10 are 1 and 10, and 2 and 5. Every whole number greater than 1 has at least two factors, the number 1 and itself. To find all the factors of a number, like in example 1 for the number 18, it's easiest to start with 1 and work your way up systematically. We start with 1 times 18, then we check 2 times 9, then 3 times 6. We check 4 and 5, and they don't work. Since 6 is already in our list, we've found them all. The complete list of factors for 18 is 1, 2, 3, 6, 9, and 18. Now for multiples. Multiples are what you get when you multiply a number by any whole counting number, like 1, 2, 3, and so on. The multiples of 5 are 5, 10, 15, 20, and the list never ends. They are infinite. Finding a multiple is just skip counting or using your multiplication tables. In example 2, we find the first 5 multiples of 7. We simply multiply 7 by 1, 2, 3, 4, and 5. 7 times 1 equals 7. 7 times 2 equals 14. 7 times 3 equals 21. 7 times 4 equals 28. And 7 times 5 equals 35. So the first 5 multiples of 7 are 7, 14, 21, 28, and 35. When we look at two or more numbers, we can find common factors, the factors they share. To do this, you list all the factors for each number, and then circle the ones that appear in both lists. This is a very helpful technique, especially when you need to simplify fractions to their lowest terms. Let's find the common factors of 12 and 30 in example 3. The factors of 12 are 1, 2, 3, 4, 6, 12. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. Comparing the lists, the common numbers are 1, 2, 3, and 6. These are the common factors of 12 and 30. The most important common factor is the greatest common factor, or GCF. It's simply the largest number in the list of common factors. The GCF is your go-to number when you need to reduce a fraction. For example, if you have the fraction 12 over 18, you can divide both the numerator and the denominator by their GCF to simplify it. Let's find the GCF of 15 and 25 in example 4. The factors of 15 are 1, 3, 5, 15. The factors of 25 are 1, 5, 25. The common factors are 1 and 5. Since 5 is the largest number in the common list, the GCF is 5. This means 5 is the largest number that divides into both 15 and 25 evenly. For larger numbers, listing all the factors can be slow. A faster way to find the GCF is using prime factorization. You break down each number into its prime factors using a factor tree. Then you look at the list of primes and identify all the primes that both numbers share. Multiplying those common prime factors together gives you the GCF. Using prime factorization in example 5 to find the GCF of 24 and 36. The prime factors for 24 are 2 times 2 times 2 times 3. The prime factors for 36 are 2 times 2 times 3 times 3. They share 1 2, another 2, and 1 3. Multiplying those common primes, 2 times 2 times 3 equals 12. The GCF of 24 and 36 is 12. The GCF has another cool use in algebra, the distributive property. You can rewrite an expression like 12 plus 18 by pulling out the GCF. Since the GCF of 12 and 18 is 6, we can rewrite the expression as 6 times 2 plus 3. Notice that 6 times 2 equals 12, and 6 times 3 equals 18. This is a way to simplify expressions for later work in math. Now we switch to common multiples. These are the multiples that two or more numbers share. Since multiples go on forever, we usually only look for the smallest few. To find them, you start listing the multiples for each number until you see the numbers appear in both lists. Let's find the common multiples of 4 and 6 in example 6. The multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. The multiples of 6 are 6, 12, 18, 24, 30, and so on. The first common multiples we find are 12 and 24. The list of common multiples is actually infinite, but these are the first two. The most useful common multiple is the least common multiple, or LCM. This is the smallest number that two or more numbers share as a multiple. The LCM is critical for adding and subtracting fractions because it helps you find the least common denominator, which is necessary before you can combine the fractions. In example 7, we find the LCM of 8 and 12 by listing. Multiples of 8 are 8, 16, 24, 32, 40, and so on. Multiples of 12 are 12, 24, 36, 48, and so on. The first number that appears in both lists is 24. Therefore, the LCM of 8 and 12 is 24. This means that 24 is the smallest number that both 8 and 12 can multiply up to. Similar to GCF, there's a quick way to find the LCM using prime factorization for larger numbers. Break down both numbers into their prime factors. This time, you take all of the common prime factors once, and then you multiply that by all of the factors that are left over. This ensures you account for every necessary prime. Let's find the LCM of 10 and 15 in example 8. The prime factors of 10 are 2 times 5. The prime factors of 15 are 3 times 5. They share the prime factor 5. The remaining factors are 2 and 3. To find the LCM, we multiply 5 times 2 times 3 equals 30. The LCM of 10 and 15 is 30. The LCM is used in time and scheduling problems. If one bus arrives every 8 minutes and another bus arrives every 12 minutes, you want to know when they'll show up at the same time again. The answer is the LCM of 8 and 12, which we found is 24. They will both arrive at the stop again in 24 minutes. This solves a real-world timing issue. The GCF solves problems about creating the largest possible equal groups. Imagine you have 12 apples and 18 oranges, and you want to make the largest number of identical fruit baskets with no fruit left over. You need the GCF of 12 and 18, which is 6. You can make 6 baskets, and each basket will have 2 apples and 3 oranges. GCF ensures the groups are as big and as equal as possible.